does this represent a function of x? Is y a function of x? The answer is I have no clue. Initially, that's the initial answer. I have no clue. Not until I solve for y. Once I solve for y, I'll know how to answer. So in order to solve for y, I have to solve for y squared first. Moving x squared to the other side. Agreed so far? Yes? Okay, then I have to do what to both sides? I cannot square. I can, you're close. I can take the square root, right? The process of squaring is when I say x times x, but the process of taking square root, so I apply the square root to both sides. Excellent. So then the left-hand side is y, and the right-hand side is
minus negative x plus 4, or
we solve these equations. We know how to solve such an equation. When we take the square root, what do we do?
Factor.
Go back to your notes. So let's go back to our notes where we applied the process of taking square roots. It's the second method in solving quadratic equations.
oh, plus or minus.
Thank you. And then what? I cannot simplify a sum. So if the radical underneath is a sum of terms, so this is called the radicand. If the radicand is a sum, you cannot separate it. If it's a difference, you cannot separate it. So please remember that. So the square root of a squared plus b squared does not equal the square root of x squared plus the square root of b squared. You cannot make that mistake, please. But you can write ab equals the square root of a multiplied by the square root of b. That is acceptable. But when the radicand is a sum or a difference, you cannot separate the radical. Please remember that. Is it a little blurry?
Yeah.
Is it better now?
I thought it was just me.
I thought it were my glasses. Okay, so is this clear? Okay, so now we haven't answered the question yet. We only solved for y. Very good. So if I manage to show, let's say, that for x equals 0, when x is 0, how much is the square root of 16? 4. How many solutions we get? Exactly. Awesome. When y equals negative 4 and y equals 4. Now, knowing this, how will you answer the question, is y a function of x? Of course not. I found one x for which it could correspond to y values, right? That's what we said. Let's go back. Remember, if you do not redo the problems we do in class diligently after each class, it's going to be difficult in the long run, and I don't want it to be difficult for anyone. So, for this x value, like 0 in my example, I found y equals 4 and y equals negative 4. Is this a function? It's the same idea, right? For x, like here. For x equals 0, we have 4 and we have negative 4. Is this a function? No. So we will answer now, since we found it's sufficient to show one x value corresponds to different y values. You don't have to continue. This is sufficient. So based on this, I will say y is not a function of x. Because I found one x value corresponding to two different y values. Is this clear? Everyone? Yes?
So we always use a 0 to like find out.
Let's use another one. Give me another value. Let's say 3. Good. So let's see what we get with 3. 3 squared is 9, with minus in front is negative 9. 16 minus 9 is 7. plus the square root of 7, negative the square root of 7. I found another x value with two corresponding to two y values. It doesn't matter which value you get, as long as it's in the domain. So for example, if you plug in 100, you're not going to be able to determine a real number. Because 100 squared is 1,000. 100 squared is 10,000. And with minus in front and plus 16 would be a negative number. So you're not going to be able to take the square root and get a real number. It will be imaginary. As long as you pick something here in the domain, you will always get two solutions. But you do not have to show 2 points. If you show this one, you don't have to show this one. It's sufficient. Any. If you show for any that it does not work, you find that for one x value on the other, there are two corresponding y values, it's sufficient.
So if you see a y squared, then you can automatically.
Most probably, yes. Yes. Again, I don't want to give a recipe unless I look at the problem that you know, I just don't want to give recipes, but more, yeah. Good, very good question, thank you. Anything else? Did you encounter anything else that we have not looked at? Anything? Anything? Okay, in that case, let's go back to that difference quotient because I need to explain what it is. You do not have to memorize the formula in this class, but I think it's better to if we know what it is. It will be easier to remember. So let's go back to the whole graph. We have a function. We created 2 points on the function P and Q. You don't have to copy this if you already have it. It's up to you. So we found that I told you that P, the x coordinate of P is x. What would be the y coordinate of P? Good. And I said Q is really very, very close here, but imagine that I zoom in. Because if I don't zoom in and if I put Q right here, you're not going to understand what I'm trying to do. So just imagine that they're very close. How close? Pretty close because look, the x coordinate of Q is x coordinate of P plus tiny bit. And of course, the y value will be the corresponding to x plus h. So this will be, as you told me last time, f of x plus h. Now we want to determine what is called the average rate of change of this function, if you want it, between 2 points. So this line is a secant line. A line that crosses the graph in 2 points. This will be a tangent line. This has nothing to do with trigonometry. It's just called a secant line. It comes from Greek or Latin. So a line that passes through 2 points or crosses the graph in 2 points. And we know how to determine, if you remember, I'm going to write the formula one more time. How do we determine the slope of this line? y2 minus y1 over x2 minus x1. We remember that. I'm going to write it again. So, and what does this represent? So the slope of the line PQ, definition y2 minus y1 over x2 minus x1, and this is f of x plus h minus f of x divided by h. We did that last time. X plus h minus x would be just h. What is the significance of this? Okay, why do we calculate it? Why is it so important? So my hope is that you will remember this. So this is the rate of change of function f of x between P and Q. And that's what we are trying to determine. Now, we do not do this in this class, but since Q is very, very close to P, this number or quantity, it could be a number, it could be a function as a result, will really give us the instantaneous rate of change, very close to the instantaneous rate of change at a point. Not just the average rate of change between 2 points, but almost the rate of change at that point, at P. What's the difference between average rate of change and instantaneous rate of change? Here's the difference. Let's suppose I get in my car to go to New York. And at some point in time, you call me and you say, where are you? And I'm going to say, I'm passing by Wilmington, Delaware. Okay, and you're going to ask me, tell me your average rate of change from the moment you started till Wilmington, Delaware. And I will calculate as the distance I covered over the time that I used to drive between here and Wilmington. That's the average rate of change between 2 points, between, let's say, Baltimore and Wilmington. I measure the distance and I divide by the time that I drove. That's the average rate of change. But then you can call me later and say, where are you? Or I'll tell you where I am. And you say, what is your speed right now? And I don't have to calculate anything. I look at the odometer and I say 65. That's the instantaneous rate of change of distance with respect to time, my speed. The average is between 2 points. But this eventually can give us the instantaneous rate of change, but that's for another class. Okay, so we have to look at different functions. We're going to pick at least quadratic functions. Determine the difference quotient. Oh, I didn't write. This is, oops, the difference quotient. The difference quotient, this ratio, you do not have to memorize it. It will be given to you in all problems. So this is the difference quotient for any function. Okay, so give me a quadratic function so we can calculate the difference quotient for the function you pick. Just any quadratic function you can think of.
X squared
Excellent.
plus 7x.
Minus 3. Excellent. Great job. This is indeed a quadratic function. We are asked to determine the difference quotient that gives us the rate of change between any 2 points for this function and simplify it. So here's the difference quotient. This formula will be given, as I said, f of x plus h minus f of x divided by x. I'm sorry. Of course, divided by x plus h minus x, but we don't need to do that again. We already simplified it. Okay. I see here 3 pieces. Piece number 1, piece number 2, and piece number 3. Which of these 3 I cannot work on? They are clearly simplified and there is nothing I can do to. And which of these pieces I have to take aside and calculate?
You have f of x.
Of course I have f of x. It's right there. You will have a minus in front. All terms will change sign. Excellent. What else I have? And I can't simplify in any way, shape, or form. Of course, this is just a tiny letter. There is nothing I can do to this. But there is a third piece, very good, well identified, that is not clear. It's not fully simplified yet. So please tell me how to write f of x plus h. Excellent. Say it again. So how do I start? I didn't hear. I'm so sorry. There is a vent right here, right on top of me, and I don't hear very well because of it.
It's gonna be like 2
Excellent.
x plus 8
In parentheses. Yes. Awesome. Yes.
plus 7.
Yes. Thank you very much. Excellent. Great job. Thank you. Now we have to dig deep. We are looking at this, and we are trying to identify what is the next step. How do I simplify this? Where do I start? How do I apply the order of operations? What do I do next?
It's going to be 2 parentheses x squared plus 2xh
You made my day.
plus h squared.
You made my day. And Bernie too, of course. Thank you, guys. Thank you. Now, the most important thing at this point is, does everyone understand this? Not just two people. Which part is not clear? Let's discuss it. It's very important. Which part is not clear? If you're asking how we got from here to here, I'm going to say the first day of classes. Let's go back to the first day of classes.
And that's the difference I want to do.
Let's go to the first day of classes notes, please. If you took that, right? Say it again.
Multiply. Multiply 2 times.
We are squaring a binomial and we get 3 terms.
Right.
If you want to foil it on your notebook, but I can't foil it anymore. We discussed that on the first day of classes. It's the first term squared plus 2 times the first times the second plus the second term squared. Nothing wrong with foiling it, but I'm not foiling it. You can, and you get full credit if you do. Other questions here? Is this okay now? Yes, Kayla, please.
So at the top when you were like, there's 3 parts,
Yes.
and
Oh, I didn't finish. I'm going to put these 3 parts together now. I only took this aside to simplify it. Now I'm going to put all of them together and continue.
So yeah, but I have a question.
Yes, of course.
So that f of x plus h
Mhm.
in the formula up there, is that at the bottom?
Yes.
Okay.
Because the function, if you remember, the function says this.
I just
And now this is x plus h. So this is x plus. Okay, very good. Yes. Yes, please.
Well, like what we got at the bottom is going to be on the top line.
It's going to be just this piece.
Just that piece.
Just that
Okay.
piece.
Okay.
Very good questions. Anything else? Anything else? Are we okay now with everything? Better? Yes? Awesome. Okay, so now let's put everything together. This is just the first example. We're going to have another, so don't worry, you will understand this, I guarantee you. So now the difference quotient is, I'm going to copy 2x squared plus 4xh plus 2h squared plus 7x plus 7h minus 3. This, it's only this piece. Now minus changes all symbols that follow into negative 2x squared minus 7x, this is minus, and plus 3. And the denominator is h.
it's like
You've seen this before, I think. Okay, now, before we even look at all this gibberish, if you want, somehow, I'm going to say this. Every time we determine the difference quotient for any function, 2 things must happen in this particular order. All terms without h at the top have to cancel out. If they don't, they made an error. Maybe some terms with h will go away. That's a bonus. I don't care. I don't know. That's nice. But all terms without h at the top must go away. And after that, second step, this little h from the denominator must go away. So one more time, 2 steps, or 2 ideas to keep in mind. 1, all terms without h must go away. And in the next step, the h in the denominator must go away. So let's see if we are on the right track. Should I write these 2 down?
Yeah.
Okay, very good.
And I also have a question.
I'm sorry?
I said yes to your answer, and then I also have a question.
Yes, ask your question first.
Before we continue, just so I don't get confused, when you wrote down on the first, above the first line, from f of x, you plugged in the 2x at the end, to the right, down there, to 2x minus 7x plus 3. I just want to know why the signs changed.
So I copied, first of all, I copied all this, which is this.
Okay.
Then I reached the negative sign
Okay.
that needs to be
Right, okay.
distributed to all 3.
You just changed the signs?
Negative 1 times positive 2x squared is negative 2x squared. Negative 1 times 7x is negative 7x. Negative 1, yes, perfect. Negative 1 times negative 3 is positive 3. Okay, So I'm going to write those two happenings in a second. Just negative 2x squared with positive 2x squared. The negative 7x with a positive 7x. And the positive 3 with a negative 3. And this is what I was hoping for. And then how many terms are left in the numerator, please? What do they have in common? And they have to have something in common. That's how in the second step, the h from the denominator gets simplified. So we have a 4x inside plus a 2h and plus 7. And you can say, what is this? And I will say, this is the rate of change of this function between any 2 points. Okay, so every time we determine and simplify the difference quotient for a function, two things must happen. Number one, all terms without h must simplify in the numerator, and h from the denominator must go away. That's step 2. H from the denominator will simplify last. Now notice that there is still an h in the final answer, but it's not the h from the denominator. It's a different h, the same h, but not the one from the denominator. That will always be the case. Any questions about the difference quotient? Should we choose another problem? Okay, please choose another function. And then I'd like to talk about odd and even functions and max min. Okay, can you give me another function, please? Any function? Negative 3x squared plus 7x plus 10. We're asked to find the difference quotient, which is f of x plus a little bit minus f of x divided by a little bit. Which portion we need to work on? Which piece of the difference quotient we need to work on first? Which one?
X plus a little bit.
Yes, you mean the f of x plus a little bit. Yes. Can anyone dictate what does this represent? This one is clear. This one is clear. There is nothing I can do to those two pieces. I have to work on that, though. This is how we evaluate this function for x plus h. Can anyone tell us what to write?
Negative 3,
Very good.
plus 7, x plus h, plus 10.
Very good. We have to continue simplifying it. This is good, but it's not good enough. We cannot put it in the difference quotient like that.
Can you put it in there for the equation over time?
We're just evaluating. We're just evaluating.
Equation is what I'm saying.
You're working for this,
No, I got it. Thank you.
the function?
Yeah, thank you.
Okay. I wasn't sure how far up. Is it okay now?
Yes.
Perfect. Perfect. Thank you. So let's continue. How do we simplify this? What is the next step?
Negative 3,
Yes.
and then you FOIL, if you want to FOIL, but 3 times.
Yes. And they are?
X squared plus xh, right?
Please go back to the first day of classes. We have an agreement. I don't want anyone to have difficulties with this. So this is negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h plus 10. It will only take you longer. Yes?
Okay. So you got the negative 3 parentheses x squared plus 2xh. Where's that 2 come from again?
You remember a month ago I said somebody will ask where the 2 is coming from. There are two terms that are like terms, and we have to combine them.
Okay.
And it's my friend Kayla. She had to do that.
It was just a trick question. I knew the answer.
Good, awesome. Perfect recovery.
I'm just kidding.
Awesome. Good. So then we are ready now for the difference quotient. We will put all three pieces together. And as you've noticed, I always kind of run out of room. So negative 3x squared minus 6xh minus 3h squared plus 7x plus 7h and plus 10. And I distribute negative 1 plus 3x squared minus 7x and minus 10. What do you expect now to happen? If it doesn't, then you know something is wrong. Say it again. Yes. Yes. Terms without h must go away. Let's see. Gone. 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 How many terms are left? What do they have in common? They have to. Because the next step requires this to happen. If it doesn't, then something is wrong. What do we have left in parentheses, please? Excellent. Careful. Minus. Yes, and plus. That's it, and that's the final answer. Notice that there is still an h left in there, but not the one from the denominator. Any questions for this?
Will they ever give us the other and have us find the f of x?
No. No. In order to find it, don't forget what you want to ask. In order to find the difference quotient, you have to be given the function. Yes, yes, yes. Please, go ahead.
So the h at the bottom of the formula will eliminate one h from each.
But you have to pull it out.
Right.
You have,
and then,
yes.
so if it's negative 3h squared.
That's why
it's
because
only
all
one
terms
h.
because all terms without h are gone.
Okay, so it just turns into just negative 3h instead of h squared. But it's in the road negative
That's
3h.
true. That's fine. I understand what you're saying. H times negative 6x.
Okay.
H times negative 3h. H times positive 7.
Okay.
We factored out.
Okay.
The common factor. Very good. Very good question. Okay. That was the difference quotient. Yes, please.
So when you write the answer, like if you were, like, do you just want that, or do you want it to say like f of x equals this?
No, this is not f of x.
I know it's not f of x, but I didn't know if you just wanted.
Just the difference quotient dq equals this.
Okay.
That's
I
it.
didn't
That's
know if, like on a test,
no.
like how you want.
no, that's sufficient. Exactly how I write it. You don't have to write anything else.
That's the answer.
That's the final answer. Correct. Yes. Okay, so let's take a look at a graph and discuss a few items here, and then we'll look at some problems. Okay, here's a graph, and you'll tell me whether this represents a function. Does it represent a function? By the vertical line test, this is a function indeed, so this is f of x. And I'm going to put some numbers here. I'm going to say 10, 9, 15, 4. Would you agree that between negative infinity and 10, the function is increasing? Good. This is called a relative max, because I can show an open interval, an interval around that point where all the other functions' value are smaller, right? Left and right smaller than that height of 9. Would you agree that between x equals 10 and x equals 15, the function is decreasing the way I graphed it?
Yes.
Okay. And of course, what do you think this point will represent? Very good. It will be a relative min. And beyond 15, would you agree that the function is increasing? Okay, so if I ask where the function has a min, you will say at x equals, excellent. If I ask how much is the min, you will answer it is excellent. That's the correct answer. So when we are asked where, we are asked the location, the position. When we're asked how much, when we're asking, the problem is saying find the minimum or the maximum, we're asked about the y value. When we're asked where it is, we're asked the position, which means x. How much is the y? Very good. Okay, I want to talk about symmetry, and then we can work on problems. Functions can be symmetric. Two different ways. They can be even. The name has nothing to do with even numbers. Or they can be odd. The name has nothing to do with odd numbers. If you ask me why they picked these names, I will not be able to tell you. Okay, so let's take a look. I'm going to graph a function, and we'll talk about it. Let me see the time here. Oh, I'm fine. Here's the graph of a function. Does it appear to you that this function has a symmetric graph? It appears to be symmetric. Yes, my graph I know is not perfect, but it appears to be symmetric with respect to the y-axis. They should overlap. Okay. I'm going to draw a horizontal line. I'm going to create 2 points on the graph. I'm going to say that this is x. I'm going to write that this is x, and I'm going to ask you, without looking at the other side, please tell me what is this? This is our function f. This is the x value. How much is the y value of this point? Thank you very much. Good. Now, without looking on this side, this is negative x. So please tell me, for this function, which is f of x, this is the x coordinate of this point. Can you please tell me how much is this? Say it again. Excellent. Thank you very much. So indeed, this is f of negative x. So now I would like you to give me the relationship that you think exists between f of negative x and f of x. What do you think? What is the relationship between these two values? This is f of x, and this is f of negative x. What do you think? Of course, absolutely. They must be equal. If a function is symmetric with respect to the y-axis, symmetric, this is how lazy people write w with respect to, WRT, with respect to the y-axis. If a function is even, it will be symmetric, its graph will be symmetric with respect to the y-axis, and the relationship between f of negative x and f of x will be this. So let's look at an example right here. So let's say f of x equals negative 3 x to the 4th plus x squared. asking, is this function even? I don't know. Maybe. I have to calculate. I have to calculate this, because this I have. I have to calculate this, and if it happens that it's identical with f of x, then I will say it's even. If this quantity that I will calculate in a minute does not equal f of x, I will say no, it's not even. So let's calculate f of negative x. Can anyone dictate f of negative x? I know everyone can, but will anyone dictate? What do I have to do? Thank you, Bernie. Of course, this is it. All I have to do is just evaluate. F of whatever equals negative 3 times whatever to the fourth plus whatever squared. Okay, so can anyone give us negative x squared? How much is that? And negative x to the fourth, how much will that be? So negative x to the fourth is what? And negative x squared? Yes, of course. So this is negative 3x to the fourth plus x squared. And it does equal f of x. This is the identical function. Replacing x by negative x didn't change anything. Therefore, the function will be symmetric with respect to the y-axis. Questions? Questions?
So symmetric as long as
As long as f of negative x equals f of x.
the
Or when I replace x in f by negative x,
something both changes.
nothing changes. It's the same thing. F of x and f of negative x are identical. The function is even. Here's a second possibility. Any questions? Anyone? Any questions? Okay, here's the second possibility. Does anyone remember this function that I used here? Anyone? I used the function f of x equals x squared. Okay, this was another very familiar function. I'll ask you in a minute if you remember what it is. So for now, let's say f of x. Here's what I'm going to do next. I'm going to connect a point in the first quadrant with a line segment going with a point from the third quadrant with a line segment going through the origin. In this particular case, this piece equals this piece. Here, this piece equals this piece. Here, this distance equals this distance. These two are the same. Okay, like before, I'm going to create a point, and you're going to tell me what is this. Thank you very much. Of course, it's on the other side, identical, negative x. Forget about that, and just tell me what you have here. Anyone?
Negative x.
This is negative x right here. But what is this? Corresponding to it, negative x.
Negative x.
Thank you very much. And now I would like you to give me the relationship between these. You can no longer say equal. Look at this. This one is somewhere here and the other one is here. So they cannot be equal. Here they are. For an even function, they are. F of x and f of negative x are the same value. But what about this? What is the relationship between these two now? What do you think? If this line segment is the same with this line segment, the same distance, What can you say about this distance and this distance? That's what it means, right? This distance is this. This distance is this. But they can't be equal. What do you think? Are they both positive? Are they both negative? From my graph, is f of x positive or negative? Perfect. Excellent. Is f of negative x positive or negative? So that's the relationship. One is the opposite of the other. They are the same, but opposite. So this is symmetric with respect to the origin. An odd function is not symmetric with respect to the y-axis, but symmetric with respect to the origin. Symmetric with respect to the origin. Yes. If this is 7, this is -7. Yes. Still equal but opposite. Yes. So let's look at an example. Let's say f of x equals 2x to the third minus x. Is this a function that is odd? I don't know. I have no idea. I have to calculate. What do I have to calculate? Say it again. Yes, I will also calculate this, but I have to start with this. But that's correct. Absolutely. I will have to determine negative f of x, which is very easy to determine. I multiply both sides by -1. But also my starting point has to be here, because I do not have this. So let's find f of negative x, like you told me a minute ago, is this. Negative x cubed still stays at negative x cubed times 2. So this becomes negative 2x cubed and minus x. Minus x was plus. Since these two are equal, the negative f of x and the f of negative x are equal, then I will say the function is indeed odd. So what I would like to work on right now is on some problems that are asking us a lot of things about a function. And then look at piecewise defined functions. Ready? So first I'd like us to look at these graphs. Is this function, first of all, is this a function? Does it represent a function? By the vertical line test, it's a function. Is it odd, even, or none of the above? Yes, because you can fold it with respect to the y-axis. Yes, it is even. What about this one? It's an odd function because it's symmetric with respect to the origin. What you see in the first quadrant, you have an identical copy in the third. Good. What about this? Is this odd, even, or none of the above? Odd, because what you have here, you have a copy here. Exactly the same type of function, reversed. You can connect it with a line segment going through the origin. Both segments will be the same. Okay, what about this one? Is this odd, even, or none of the above? No, it's not, because what I have here, I don't have a copy here. What I have here, I don't have a copy here. So it's not, I cannot fold it with respect to the y-axis, and I cannot fold it with respect to the origin either, to say nothing about this. Nothing. Very good. Yes, it's not symmetric. Good. Now I would like us to look at a graph and answer all these questions that they have for us. This one or any other function that you would like to choose.
page is that?
We are on page 251. Very good. I just want to make sure I explain everything from scratch. Okay, ready? And I do need my pencil. We have tons of questions here, and I'm going to add more questions. So, is this a function? It is a function. I'm also going to write the answers on a piece of paper. So that was number 6 for us. So this is problem. If you have your books or laptops, it's fine. So this is problem 50 on page 251. So it is a function by the horizontal line test. Okay. Second question is asking us to find the domain of this function. Can anyone give us the domain of this function?
-4.
Domain, please.
-infinity to -4 union 4 to infinity.
So the domain is any possible value of x that I can plug in this function. Can I ask you to find f of -5? Yeah. I have to extend the graph, but I can't. Can I ask you to find f of -100? Yes, I would have to extend the graph according to this, and it would be difficult for me to tell you what it is, but yes. Can I determine f of -3? Yes. Can I determine f of -1? Yes. F of 0? Yes. F of 2? Yes. F of 4? Yes. F of 100 million? Yes. So what is the domain of this function? All your numbers, very good. Now we are asked about the range. So the range is measured on the y-axis from the lowest y value till the largest y value. So what is the range then for this function? -infinity to 4 inclusive with a bracket. Very good. Next question. Are there x-intercepts? Yes. Can anyone read for us the x-intercepts? -4, comma 0, comma, and 4, comma 0. Do we all agree with the x-intercepts? -4, 0, and 4, 0, correct? Good. Next question, the y-intercept. Can anyone give us the y-intercept in the ordered pair format? Do we all see the 0, 1 y-intercept? Okay, perfect. Awesome. The intervals on which f is increasing. So if you'd like to follow my marker. On which intervals is the function increasing? Not from which value till which value. On which interval is the function increasing? From -infinity till
-2.
union.
0.
Excellent. So f increasing on -infinity to -2 union 1 to 3, 0 to 3 you said, correct.
That was finding out the what again?
Increasing.
No, he just like say
On which intervals is the function increasing? Yes.
How
On which,
did you write the answer? You mean -infinity, but like. Okay.
f increasing on -infinity to -2 union 0 to 3. I prepared this for you while I would talk. I'm writing on it. Intervals on which f is decreasing, please. F decreasing on? Do we see this? -2, comma 0 union. Okay. So it's not clear. So let's talk about it. It's increasing between these two x values.
Oh, and then it starts.
It's decreasing between these x values.
Okay.
It's increasing between these x values. It's decreasing between these x values.
So again, you're just mentioning the two increase and the two decrease.
Yes,
Gotcha.
exactly, because there are two pieces. Very good. So negative 2, 0, union,
And then negative 3. Or, and then
3 to infinity. Awesome.
Or,
Values of x for which f of x is less than or equal to 0. We have to talk about this.
I have a question.
Please do.
When you write that, do you put brackets on the negative
Never
two?
brackets, parentheses. Because at a particular point, the function is constant.
Okay.
I don't, nobody, be careful because they, my, what is it called now? My lab math may consider with brackets,
Okay.
but it's wrong.
Okay.
Parentheses only.
When would you use brackets, in what circumstance?
You cannot put brackets, it's about the trend. At a particular value, for example, at x equals 3, the answer is 2. It's not, 2 is not increasing or decreasing. The function is the trend is between 0 and 3 increasing. Not at a particular point. At a particular point, the function is constant. So, for example, I say, how much do you have in your pocket right now? And you will say $10. That's not increasing or decreasing. You just have 10.
Yeah.
But I can say, between 2000 and 2010, your salary increased. The trend is increasing. But at a particular moment in time, you don't have an increasing amount in your pocket. It's just fixed, right? Good. Any questions here? Yes.
I just didn't get the answer for the x-intercept. It's two answers, right?
Yes.
And
So
you just
negative 4
wrote the
comma
two.
0 and 4 comma 0.
Okay.
Okay, so here's the next question. Let's look at this graph and analyze the following before I tell you the question. I think I did say it, but it's not important. Let's analyze the graph first. I hope you agree that if I ask you to evaluate for negative 5, it will give me a negative number. Correct? Yes? If I ask you for negative 10, you will also give me a negative number if you were able to see the graph. But if I ask you to find the function value at negative 3, you will not give me a negative number, right? You will give me a positive number. What about at 1? You will also give me a positive number. What about at 3? You also give me a positive number. What about at 4? You will say 0. But what about at 5? What would you say at 5? So for which x values the function is positive, and for which x values the function is negative? Between negative infinity, you're talking about the domain, right? We know the domain. Between negative infinity and negative 4, union, the function is, of course, it's below the x-axis. Must be negative. And between negative 4 and 4, the function values will be why? The graph is above the x-axis. Does it make sense? So now we are answering the question. The question is, for which x values is f of x less than or equal to 0? And you tell me and I'll write it. Which x values will make the function negative? Very good. Excellent, with a bracket. Right, union, 4 to infinity. Thank you very much. Great job. Is that clear?
You don't give the other one, the other side.
Yes, I said union, 4 to infinity. The numbers at which f has a relative max. The numbers at which it has a relative max. Position of relative max. Can anyone give us the position of the relative max?